Hello, my dear students. In the last video, we have seen that some metals, where they when it come they when they come to contact when they come in contact with water, they produce hydrogen gas, and a huge amount of energy is produced. This huge amount of energy is caught by hydrogen. So this hydrogen catches fire and it may cause a blast or an accident. So these metals like sodium and potassium, they should not even come in contact with water or a moisture. So what should we do to prevent the contact of metals like sodium or potassium with water or moisture? Sodium and potassium metals are kept immersed under kerosene oil or paraffin oil or simple oil. So remember, my dear students, that the sodium or potassium metals are always stored under oil. This oil may be kerosene oil, it may be paraffin oil, or it may be any other oil. This may be the reason that may be asked into the exams, that why the sodium or potassium are kept under oil or paraffin. We have seen that metals like sodium and potassium are highly reactive and they displace hydrogen from water. Metals like aluminum, zinc, iron, magnesium do not displace hydrogen from water. So, when you add aluminum to a water, zinc to a water, iron to a water, magnesium to a water, they do not react. Remember, this water should be cold. So, these metals, aluminum, zinc, iron, magnesium, they do not react with cold water. Note, magnesium metal reacts with hot water and displaces hydrogen. So now you can understand that this magnesium metal reacts with hot water and displaces hydrogen gas. You can see here that when we take a magnesium and if we have again the hot water, this hot water of two molecules of hot water, we can write it as 2H and 2OH. This 2H turns into H2 and this 2OH combines with magnesium to produces magnesium hydroxide. This is nothing but your magnesium hydroxide. And again the hydrogen gas is produced. So here you can see that the hydrogen gas is produced. In front, in the form of bubbles. So see this hydrogen gas which is produced, it is in the form of the bubbles. These bubbles of hydrogen sticks to the magnesium metal. This magnesium metal floats. Remember, this is an important point. So you can understand it with the help of the figure. This is the container. In this container, we have added the magnesium metal. When magnesium metal added, again, the hydrogen gas start producing. These are the bubbles of hydrogen gas. These bubbles of hydrogen gas actually, after some time, they stick to the metal surfaces, and this metal, which was at the bottom, start uh, start floating on the water. This is what you have seen even in the case of the acid. You might have seen, if you can remember the activity, that we have seen that magnesium metal was not going to the bottom; it was floating on the surface of acid. I would recommend you to watch the activity once again if you want to see that magnesium metal was floating rather than it was available at the bottom. So the same thing happens with the calcium also. So instead of magnesium metal, if you take calcium metal will also produce hydrogen gas. This hydrogen gas again reacts, these hydrogen bubbles again, they are available on the surface of this metal, and the calcium metal start floating. But remember, my dear students, that calcium metal can even react with the cold water, and calcium metal produces hydrogen gas. During the reaction of the calcium metal and cold water, energy is also produced, but this energy is not enough to make any accident or to burn hydrogen gas, so that the accident or blast is not possible, and that is why calcium is not required to be stored under kerosene, but calcium metal floats on water. Whatever happens with magnesium metal in hot water, the same thing happens with calcium metal in cold water. But in both but in case of both calcium and magnesium, heat produced is not enough to cause any accident or blast. You can see here that calcium metal actually reacts even with the cold water. Again, you can write here that this 2H2O is your 2H and 2OH. So this is how you can, calcium combines with 2H to give you CaOH twice, and this 2H turns into H2. Even here the heat is produced, but the heat produced is not enough so that this hydrogen gas catches fire and there is no oxygen, and there is no blast or there is no accident. Iron and aluminum metals cannot displace hydrogen from cold or hot water. Remember, my dear students, that iron and aluminum metal, or even a zinc metal, you can even write aluminum and zinc. So, iron and aluminum and zinc metals cannot displace hydrogen from cold or hot water, but what? We'll study into the next video. I hope you are enjoying. Happy learning.